So this is Will's group. Will, can you tell me what your two groups got sorted into, please?
The one on the right is slightly linear and very linear, and the one on the left is little to no correlation.
So like linear, at least kinda?
Yeah.
That's the technical terms. And the left side seems like it's a bunch of rando.
It's little.
Okay. Anybody else have similar categories? Like or we might say some fancier words. These ones look like they have correlation, and these ones look like they have no or little correlation.
But what about J and I?
Well, I like that. So J and I could draw a line of best fit that kind of hits the data. Kinda. But and like A you could, right? But kinda. This one you kinda. So that's why I said little, no or little. Okay? Awesome. Did anybody else organize theirs these ways?
Yeah.
Okay. I want you might have, maybe not. I want everybody to try to organize them a different way now. Yeah. Let's take a look at Hadley's group. So Hadley, I'd let Hadley do 3. Even though I think at least one of these could go in one of these. But
Yeah, I think we could probably.
okay, so Hadley, tell me what this top group, what you got going on up here?
Well, the top left is positive,
What do you mean positive?
positive slope.
Oh, so if we had a line of best fit,
Yeah.
you're saying these lines of best fits would all be positive.
Yeah, and then the top right
Okay?
is negative association or negative slope.
Negative. Okay? And we're going to use this word, this fancy word. You ready? Correlation.
Yeah. Correlation.
Okay?
And then the bottom two, I don't know where they're supposed to go. I mean, I guess you could maybe put these.
Yeah, like so if we knew a line of best fit, it looks like maybe there's one like here in this one. But this would be like little to no correlation maybe. And I know it said make 2 groups, but like you can maybe do a line of best fit on this one. I don't know, maybe it's like this. Maybe.
I mean, a lot of them.
There still is a line of best fit. It just might not fit much of the data, right? So I like this. So those are the 2 big ideas we need to look at.
We have another one.
There are other ones. So we talked about 2 things here. Check it out. There's 2 ways we classified these. Okay, Stella? We had little or no correlation, so kind of rando, versus things were tighter. Everybody follow that?
There are 2 that I think are actually.
Okay. Then we talked whether they were positive, negative, or actually not very much of each. Those are 2 different ways we kind of classified all those, right? You guys see those 2 ways? Yeah, that's what I needed us to get at today. So we're going to classify based on how strong or weak a correlation is. So whether it's group tight to the line or not. What did we use to look at that yesterday? What word?
Correlation.
Residual yesterday. Today, correlation. So the residuals will tell us stuff about the correlation, okay? How close it is to the line. But now we're going to talk about whether it's positive or negative, which you guys already identified, deals with the slope. And we're also going to deal with how strong or weak it is. Because if it's a strong positive, that's much different than a weak positive in terms of knowing if our data is close to our estimate or not. All right, so we're going to formalize this a little bit more. So here's those lines of best fit. And what I need you to do next with your partner is I need you to focus on this number right here. This number is the correlation coefficient. And I want you to make some observations and inferences about what this number means in context. So there is a rhyme and reason to this number. I want you to notice some things about the number, notice some things about your graphs, and we're going to try to apply that knowledge to come up with a general idea of what this number means in context every time. You don't need to worry about calculating the number, okay? I'm also going to collect your card sorts while you're doing this, so get them all nice and tidy. So go. Make sense of that number. Make some big ideas. Eyes up here, mouths closed. So maybe we don't have it slam dunk yet, but I'm wondering what are some things you notice as you look at correlation coefficient, that R value, which you might not know it, but when we've done decimals, when we put the line of best fit in, it gives us this value. Okay? Ellie, what'd you notice?
Not like, if it's like a negative, if it's like a negative number, then it's a negative slope.
Oh, so I'm going to say something like sine matches sign of the slope.
Yeah, and then like.
I see that.
And then like the smaller the number, like the less kind of diagonal it is. The less linear. Yeah.
Okay, so you got to be careful with that. Let's talk about that. By smaller, look at -1's the smallest.
No, we mean closer to 0.
Oh, the closest to 0 means the least, so closer to 0, less correlation?
Yeah.
Has everybody found that?
Yeah.
So let's look at some that are closer to 0. Like B,
Yeah.
6, 1.
And
E,
E.
B, E, A and E aren't as much, but it is approaching 0 compared to some other stuff. Okay? What do we think about the ones that are not close to 0? Micah?
Like -1, we see that pretty much all the dots are like really close to the line.
So closer to -1 and 1.
Right. More correlation.
More correlation. Ooh, yeah, it's going to depend whether it's positive. Guys, I think we found all the big ideas.
What?
So let's check this out. This -1 is exactly on the line. Can we get more exactly on the line than -1 then? So -1 says exactly on the line when it's going negative. Okay, what happens if it was like this? Would that be more negative for correlation? Not for correlation. For slope it would, but if it's on the line, regardless, right? If it's negative, that's correlation. How close it matches the data, right? What would the residuals be on this one?
0.
Yeah. So keep that in mind. So then we look at things like C and F. Both of these are close-ish to 1, but you can see the general trends being pretty good. So the closer to 1 and -1 means our correlation is strong. Closer to 0, our correlation is weak. Positives go positive, like up. Negatives go negative, like down.
Is it possible to go past 1 or past -1?
You can't be more perfect than perfect.
Okay.
So all the ranges for correlation coefficient are going to be between 1 and -1. Look at that. How much better is that than me just giving you notes? You guys found it. That's cool. Let's practice it and make sense and check it. I've got some on the next slide that don't have the writing on it yet. So let's go and make sure the big ideas you say apply. Okay? So right on the line, positive. Perfect, +1. That's as perfect as you can get positive, correct?
Yes.
Okay, let's look at this one. This number should say it is weak or strong. Weak and negative. Yeah, get that weak sauce out here. Okay, weak and negative. So close to 0, but still negative.
Pretty strong.
Pretty strong. So what's interesting is like not many are right on the line, but this shows pretty strong correlation, 0.95. It's close to 1. This shows strong negative correlation. Yeah.
Why would it be R?
I'm not sure. Well, it's also italics, so it's not just R. One thing you always have to consider in mathematics, I'm sure there's a reason I could look it up, but mathematics is kind of universal. So that means it's R like in lots of languages. A lot of things go back to Greek or Latin. I am unsure. Just like, slope's M, but it's like universal. This is going to be the correlation coefficient. Yeah. I wonder, maybe I'll try to look it up in a minute and get back. But it could be related to residual.
Yeah, it's not.
Yeah, but I don't know. Finn. Okay, cool. So this right here is the nice pretty big ideas we got. You did the work, okay? Positive, it goes up, negative goes down. The closer to 1, the more linear or more highly correlated it is. And the closer to 0, the more rando it is. We good on those big ideas? Okay, so that's what this says. I'm not going to write it again. If you're watching the YouTube video and you want those big ideas again, you just pause it right here, right? Okay. Then, I'm going to have you try to match the correlation coefficients to these 3. Which ones do you think these are? With your partner, let's go. A, who's got one? RJ, what do you think for A? Yeah, I think the coefficient is 1.
That's -1.
No, it's wrong. Because it's a positive.
Positive slope.
Well, 1 is negative.
It's going up, right to left, or left to right. So I got 8. It's perfect on the line, and it's positive. Super strong correlation, and it's positive, right? Okay, B, this one, there could be some discussion. Test.
7.
I also think 7.
I think it's 6. Because I think it
6 is halfway between really good and nothing.
What about 3?
So that looks pretty close. Look, so hey guys, Ellie has a great point. If it's 0.6, it'd be closer to the line, right? Check out this scale. I don't know if that helps or hurts us, but I think that one's intended to be 7. That looks really, like, pretty strong. There's definitely a line there, right? We could talk about 6, but as you see some things, I think 6 is going to show it being a little more, like, half random. This doesn't seem half random. Okay, C. Who's got one for C? Heidi.
2.
I would agree with 2. Very strong negative. Not perfect, but strong negative. Okay? Okay. Now, here's what's going to get interesting. I need these same values for the next page. So this is going to be riveting. I need to take a picture of our data set here.
What?
Of our options. Okay, use this photo.
Riveting.
Riveting.
Punctuals on 10.
Uh-oh, now I got to cut it. Okay, I got this. Boom. Whoops. Whoops. I'm going to get it. Boom. All right. Match them up, baby. It ain't pretty, but it's done. So let's hear what you got. Who's got something for D for me? Letter D. Raymer.
I think that's 3.
Yeah, I also got 3, which was negative 0.74. So there's definitely some. It's not super strong, but it's pretty strong, right? Okay, E. Micah.
6.
Yeah, I got that 0.65. So if you think back to the previous slide, right? Do you see that this one's weaker than that previous one? This is like half random.
I was thinking about those 2.
Spencer F. You think that's by 1 you mean? Yeah, I got you. Yeah. You can't get a stronger negative correlation, can you? Tess. G.
I said 4.
Yeah. That is 0.06. It's negative, but like kind of barely, right? Hadley. H.
And then H is 5.
Which is 0.48, which is, again, it's like half random. Cool. I think you guys got it.
So G is less correlation than H?
G than H? Yes. You can see like this trend. This trend is hard to see if you just look at that. You know what I mean? Yeah. I like that you're looking for that comparison, Grant. Okay.
Look at the scale also.
So we already know this. The correlation coefficient for this would be positive, and would it be in from weak to strong? Where would it be?
It's about like 0.75. Oh, no.
Pretty strong. It's not super strong.
I'd say like 70 something.
And positive.
The one on the right is generally negative.
What about, yeah, look at this one on the right. So this is a 0.8. Look at this one on the right. That is called weak sauce, okay?
Weak sauce.
Negative. All right, we got this. You're going to do the lesson cool down. So we can describe how well a line fits by using the correlation coefficient. That is true. Cool it down, and then I'll give you your homework.